Hi, for this video, what I want to do is take a look at a piecewise function. We are going to graph this. A piecewise function is just telling you that for a certain interval, you are going to plug any of those numbers into a particular equation. So, for example, on this one, when x values are less than 1, we're going to plug it into this one. Okay, because it does not include 1, we still must start at this point. So we always start at this point. And then you just decide that if it's less than or equal to or greater than or equal to, then you're going to use a closed circle at that point. If it's less than or greater than, you would use an open circle at that point. So for this one, what we're going to do is we're going to take and we're going to plug 1 in for x here. Okay, so if I do that, 1/2 times 1 gives me 1 plus 3 gives me 3.5. So my first starting point, when x is 1, my y coordinate is 3.5. So I would go up 1, 2, 3 and halfway up, and then I'm going to put an open circle there because it doesn't include this point, just everything up to that point. Okay, we can't go at the value 1 less than that because there are fractions in between 1 and 0. So we have to make sure that we include everything, including like 0.9999. So then what we can do is we can pick other values in this interval, like 0. 0 goes into here. If I do 1/2 times 0 plus 3, that puts me at 3. I could plug in -1 if I wanted to. -1 times 1/2 would give me -1/2 plus 3 would put me at 2.5. Okay, or I could plug in -2. -2 times 1/2 gives me -1 plus 3 is 2. Okay, so when I plug in -2, I'm at 2. And I could continue forever and ever in that manner. So basically my slope is just going to continue to go this direction forever and ever. Okay, so from -infinity all the way up to 1, but not including 1, we use those values get plugged into the first graph. The second graph we're going to use when x is greater than or equal to 1. So when x becomes 1, we now plug it into this equation. So 3 times 1, we always start the same thing at this point. So we always want to start at this point with plugging it in. And then our output is what we would plot. So when x is 1, 3 times 1 is 3 minus 2 gives me 1. So we would be at 1, 1. And then if I plug in 2, I get 3 times 2 is 6. And 6 minus 2 gives me 4. So 1, 2, 3, 4. I could have also used the slope up 3, 1, 2, 3 over 1, and I could do that again up 3 over 1 to get another point if I needed another point, but you really only need 2 points. It's very hard for me to draw a straight line this steep. So this would be the second piece of my graph. For all values greater than 1, it's going to fall on this ray. For all values that are less than 1, it's going to fall on this ray. As far as the domain and range go, you just kind of have to look at this to see what happens, to see if there's any breaks where there's no overlaps. In this case, because of the fact that if I start from x here, I'm going to be touching something all the way up on my x until I get to here, and then it's going to jump to this graph, and it's going to continue forever and ever because this continues forever and ever. So for this one, my domain is from -infinity to +infinity. There's no breaks where that's going to cause a problem. My range is also going to be the same thing because no matter where I'm at on this line, I'm always going to, because this continues forever and ever in a downward direction, I will always be hitting something on the pink line until it jumps to the purple line. So my range is also -infinity to +infinity. If you are using set notation, you can also say that this is the set of all real numbers of x and all real numbers for y. As always, thanks for watching. If you have any questions, please let me know.